So, back to what we were talking about on Tuesday. Alrighty. We were looking at solving a system of equations. Now, for the warm-up, we just solved a single equation, not a system, okay? Each problem had only one equation in it. In a system of equations, all right, you're going to have two or more equations that you want to solve simultaneously. That means at the same time. So you're going to find one solution that's going to work for both equations, that will make both equations true, okay, that will work in them and stuff like that. Okay, how do we do that? Well, one way we're going to do that is by graphing both equations. Okay, the first equation was already graphed over here for us. Okay, the slope was 1/2, this y-intercept was -4, so that was our line right here. The other equation was not in slope-intercept form, so we put it in slope-intercept form by solving, bless you, by solving for y. No, you're good. There's the y-intercept of -1, and then up to right 1, up to right 1, up to right 1 gave us our line right there. So there's the first equation graphed. There's the second equation graphed right here. And then where do they intersect? Right there at that point, which has coordinates -2, -5. So our answer is the x-coordinate -2 and the y-coordinate -5. Okay? If you plug those coordinates into this equation, or if you plug -2, -5 in for the x and the y here and solve, you're going to see that both equations are true. They both work. Okay? Then we did this. We did number 1, where they were both already in slope-intercept form, and so we just had to graph them. Again, identifying the slope and the y-intercept, slope and y-intercept, and graphing them. And we found the point of intersection right there at the point 2, and then, what was it, 5, 2 positive 5. Okay? So let's go over now to number 2. Actually, any questions up to that point? Okay, we're all refreshed, right, about where we were, what we were doing. So let's go to number 2 then. Okay? And see what's going on here. All right. So, number 2, here's our system. Again, we're going to solve both of these equations simultaneously. We want to find the one answer that works for both of these equations. Okay? So, let's go to Jackson. So Jackson V. Okay? Are these equations ready to be graphed? Like the way it's currently written, can we graph it the way it's written there? No. What do we need to do to be able to graph this? Solve for y. You got it. Okay, so let's take that 2x plus y equals -3. Okay, this is just like we did in the warm-up, right? How will we get that by itself, Jackson? What should we do to get the y by itself here? You got it. Good job. Subtract 2x from both sides, okay? 2x's are going to cancel. We bring down the y. These are not like terms, right? This does not have an x. This one does. And so they don't go together. We're just going to have to rewrite it as -3 minus 2x like that. Okay? So, good. Jackson, what is the slope of this line? 2/1, or don't forget the negative though, so it's -2/1. Okay, so -2/1 is the slope. And what's the y-intercept here, Jackson? Oh, -3. Good job. Okay. So then we'll say b equals -3. And then we'll go ahead, let's just go over here and graph these things. Okay, so we'll count the y-intercept's -3, so down 1, 2, 3, there's our first point. Okay, and then that slope tells us sky to go which direction. That slope of -2/1 tells us to go which direction to get more points. Down how many, sorry? Down 2? Right 1, good job. And we can keep doing it, right? Down 2, right 1. Down, oop, I'm out of space. Instead of going down 2, right 1, we can also go up 2, left 1. I'm just going to keep going here to kind of fill up the graph, like so. And then I'll connect the dots. Okay, perfect. Thank you, folks. Let's go now to sorry, still trying to get names down and stuff like that. Ah, Alec. What we do then for this next one is x minus 2y equal to 6. Are we ready to graph this one with the way it's currently written? Now what do we got to do? Get in slope-intercept form there. So what should we do then to do that? Subtract x from both sides. You got it. X's are gone. What's going to be left over here? Good. Negative 2y. And then what's going to be left over here now? Great. Okay. Last step. Take it away, Alec. What do we do? Okay. Divide both sides by negative 2. Divide both sides by negative 2. We're going to leave the y there, but just divide by negative 2. So that's gone. We'll have y equals 6 divided by negative 2. Negative 3, right? And then this is a negative 1, really, divided by negative 2, so it's plus 1/2 x, like that. Very good. And then let's go to Erica. Okay, so hi. So, Erica, what is the y-intercept of this line right here? What's the numbers tell us? What's the b? Maybe you want to think it that way. 1/2, careful. 1/2 is the number in front of the x. So that means the 1/2 is the, not the y-intercept, it's the slope. Yeah. Slope is 1/2. And that means then what's the y-intercept from here? The negative 3. Okay? So to graph, we're going to count down 1, 2, 3. There's our y-intercept. Hey, look at that. It's the same point as the other line. And then for our slope, Erica, what is that slope of positive 1 over positive 2? How does that tell us to go? The 1 means we're supposed to go up how much? Yep. And then the 2 tells us to go over to the right or over to the left? Right, yeah. So up 1, right 2, up 1, right 2, up 1, right 2, up, we're out of space, down 1, left 2, down 1, left 2, like that. Connect the dots. Okay. We got both of our lines graphed. Let's go to, someone who's here. Let's go to Alex P. What do you say here, Alex? What's the solution here?
0, -3.
0, -3. Is that what you got when you did it on your own? Wonderful. That's right. Questions on any of that? Yes?
Wouldn't you have not had to graph that because they had the same y-intercept?
So that's an excellent point. Right. So if you're paying attention here, yeah, we could recognize that, wait a minute, this line has a b of -3. This line up here also has a b of -3, and so we know that's the point they have in common, 0, -3. Yes, and so you could have avoided having to graph altogether if you were paying attention. But if you're not, that's okay, because this graphing will still show it to you too. But absolutely. It's a good thought there, John. Okay? So speaking of other kind of other thinking that we need to be able to do here, let's take a look at number 3 and 4. Okay? Let's look at 3 first here. Okay? You'll notice it's a system again. The directions here say, though, for the following equations, explain why you would not need to graph them and state the solution. Okay? So for number 3, looking at the information that we got there, kind of like what John was saying, right, where you can look at what we're given already and just kind of imagine what the graph would look like. What do we notice about these 2 lines here? What do we notice about these? Go ahead. The slopes are the same, and what is different, though? The slopes are the same, but what's different about them? That's important. The slopes are the same. What else? What's different, though? The y-intercepts are different. If we have the same slope, but different y-intercepts, what's true about these lines? They are parallel. Okay? Now, why is that important to recognize here? What do we know about parallel lines? Where do they intersect? Sky? Never. So, what's that? Perpendicular lines intersect at a right angle, or we also talk about, these are just intersecting lines right here. So, what are we going to say? Will this system have a solution to it? The answer is no, because they never intersect. Okay? So, what can we say? The lines are parallel. Same slope, different y-intercept.
So that's what makes it parallel?
Yes, same slope but different y-intercept. If it's the same slope and the same y-intercept, well, we'll talk about that in a second here. Okay, lines are parallel, same slope, same or different y-intercept. So, no solution. Okay, that's our conclusion here. The lines never intersect. Our answer is where the lines intersect. So there's no solution, right? There's no place where they intersect. All right, let's take a look at number 4 here. Number 4, y equals 2x minus 5. That one's already in slope-intercept form. But this one, 4x minus 2y equals 10, that's not in slope-intercept form. Okay, that's not. So we need to get it in slope-intercept form. Let's go to someone we haven't heard from yet. Let's go to maybe, all right, Ian. So Ian, what do you say here? How do we get this in slope-intercept form? What should we do to both sides here? I'll rewrite it here. 4x minus 2y equals 10. So what should we do? Yeah, minus 4x from both sides. You got it. Very good. That's gone. What's still left over here, though? And negative 2y. Yep. And then this is just going to be 10 minus 4x. And then what should we do? Yep, divide everything by negative 2. Good job. You got it. Y equals negative 5, negative 4 divided by negative 2, positive 2x. Okay, now, there's our second line. There's our first line. What do we notice about these two lines? So, Hannah? They are the exact same line. Exactly the same. Same y-intercept, negative 5, same slope, 2. So if they're the exact same line, where do they intersect? Everywhere. So if they intersect everywhere, and how many solutions do we have? Infinite solutions. Infinitely many solutions, or infinite solutions. Okay? Because these lines exactly overlap, okay, there is an infinite number of solutions. Any place along those lines is where a solution can be located. They're the exact same. Okay? So parallel lines, same slope, different y-intercept, no solution. Same lines, same slope and same y-intercept, infinite solutions. And then intersecting lines, okay, where they just intersect. Alrighty? Questions on any of that? Cool. All right. Can you hold on just for 1 second? I want to get you started on the next thing and then I'll let you go. Okay? Thank you for waiting. I appreciate it. All right. So this next thing we're going to look at. Let's see here. I pass on that. Everybody questions? I do, right behind you, actually. Very convenient. Okay. Kurt's going to come around and pass out some papers here for you guys. All right. We're going to work on this next here. I'm going to have you guys work on this. Well, yeah. In a second here, I'll show you what I'm talking about. Okay, everyone got one, I think? All right, great. Thank you. Okay. So let's take a look through this here. We'll go through this real quick together, and then I'll have you guys get some practice here on your own as well. All right, so. Hopefully we'll kind of rapid fire through this some, because we just talked about this. It should be fresh in our brains. All right, let's go to, someone who's here. Marilyn. So Marilyn, we're talking about solving linear systems with graphing, okay? A linear system, right, consists of 2 or more linear equations. Now you'll notice here it's specifically called a linear system. That's why it consists of 2 or more linear equations, right? A regular just system of equations could consist of 2 or more any kind of equations. Anyway, so here are examples of the system, okay, both linear equations, right? Number 1 here asks us, does the point 0, 4 make either equation true? So we're going to substitute it and find out. So in other words, 0, 4, how can we plug it in here to check to see if it works? What should we do, Marilyn?
You plug in the 4 for y,
Uh-huh.
and then the 0 for x.
Yes, it's 4 for y, 0 for x. Okay, and what is negative 2 times 0?
0.
Yeah, 0. So we get 4 equals 0. So in other words, does it make this equation true? No. Okay, now it asks for both, so let's check the other one too. We'll do the same thing you just said to do, though. Put 4 in for y, put 0 in for x. Okay, 0 plus 3, 3. Does 4 equal 3? No. Okay. Okay, so in other words, 0, 4 is not a solution to this, and it's not a solution to this. This point is not on either of those two lines. If you were to graph it, it wouldn't be on the line. Okay? Very good. Let's try the next one here. 2, 5, okay? And we'll go to Anna in the back. So Anna in the back, 2, 5. How are we going to check to see if that makes the equation true or not? Oh, Anna, not Hannah. Sorry, Anna. Anna W. Go ahead. Sorry. 5 for y. 2 for x. That's right. Okay, and we get, well, what is negative 2 times 2? And so, is that true? No. Okay, and then we'll try this one right here. Plug in 5 for y and 2 for x again. And 2 plus 3 is 5. 5 equals 5. Ah! We get it to work for the second one. So 2, 5, Anna, 2, 5 works in the second equation. It does not work in the first equation. It does not make the first equation true. So is 2, 5 a solution to this system? No. Why not? It works for this one.
Doesn't work for the first one, though.
But it's got to work for both in order for it to be a solution to this system. Exactly right. It's got to work for both. It's got to work for both. So it works for this one, that's great, but it doesn't work for this one. That means the system is not, that's not the solution to the system. Okay. Let's try that negative 1 too and see if it works here too. And I'll just go ahead and do this one. I think you guys get kind of the idea there. So again, we'll plug the negative 1 in for x. Negative 2 times negative 1 is 2. Check. It works. So yes. Okay. Now let's again check it in the second one here. 2 in for y, negative 1 in for x. That gives us 2 equals 2. Check. It works. Yes. So the point negative 1, 2, the point negative 1, 2 works in both equations. So then that makes this, since it works in both, what is it now? What does that make this? Yeah, the solution to the system. Okay, this point, negative 1, 2, works in both equations. All right, and so it makes it the solution to the system. Now, this strategy that they used here, right, not a good strategy to use. It's like essentially guessing and checking. And you don't want to just guess and check, right, with this kind of stuff. That's why we're teaching these different methods. Graphing is a good one to use, right? So what point is the solution to the system above? It is the point negative 1, 2, the one that worked in both equations. Okay? So why don't you guys go ahead, graph these two right here. You guys go ahead and try this on your own here. Okay? Graph y equals negative 2x and graph y equals x plus 3, okay, on your own paper there. Actually, Brady, you want to go right now, right? Okay, if you want to go ahead and go. And then when he comes back, you can go, okay? Sorry, I should have sent him earlier, maybe. Okay, thank you for waiting, Brady. I appreciate it. Okay, so go ahead, graph those two that I just circled right there for you on the same grid right there. go ahead and try and fill in those blanks there for number 5 as well. Okay, there's a couple blanks there with the bullets and stuff like that. Go ahead and try and fill those in if you think you can. Okay. All right, come around here and see how we're doing. I want you to plot. I want you to graph this equation and graph this equation, and then you should get the same. You should get that as your intersection points. Do you understand what he's asking now? So, what's the y-intercept for this here? Well, I mean, just look at your equation. Where's the b, right? B is like back here. There's no number written. What number would that be? 0. So you're going to start with your point there at 0. And then what's your slope of that one? Yes, down to right 1. And would you like that got a bigger? I'll get you another one. I'll get you a big one, not the other one, when I pass those out. But yeah. So now we're going to graph this. Okay. And what is the y-intercept for this equation? And then, well, what number could you put in front of that x though? And then it gives a fraction 1 over 1. So you're not 1 by 1 kind of thing. Good with that? Okay. So we're going to graph these two equations. That's what we're doing. Okay. What's the y-intercept of this equation? Well, careful. That's the slope because it's the number with that's number with the x. That's your m right there. The b is over here. What's the b? There's nothing there. It's 0. So it's a 0. So you're going to start at the 0 there. And then your slope is, what's your slope? Or as a fraction, -2 over 1. So then from here you're going to go which direction? Be careful though. You went left 1, down 2. You want to keep doing that. Actually, it should be. Sorry, it should be down to right 1, down to right 2 there. So go down to right 1, down to right 1 there. You should get the same intersection point. Good. Okay. Yep. Good. Look from the blanks there. Good. 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 Looking okay back here, Mr. Steve? Yeah. So, what is the y-intercept of this line? That's the slope. That's the number right x. What's the number right here? What number could you put there? Well, it'd be I see. It's like a 0. I mean, like after x, right? There's no number in, so we assume it's 0 is there. So 0 is your y-intercept. Put point right there. And then what does your slope tell you to do? Down to right 1. No, I didn't. Go careful to the right 1. So go this way. There you go. Down to right 1 again. Keep going. Oh. Yeah, go ahead. Sorry, all right, so then Brady, what's the other y-intercept there? This equation. What's your y-intercept is 3. What's the slope? The slope is right here. It's 1 over 1. So, what's your point on the y-intercept for 3? Up 1, right 1, up 1, right 1. Yep, and then connect those dots to make the lines. Yep. Okay. What's the y-intercept for this line? 3. There you go. And what's the slope of this line? Yes, or the fraction. Yes, so from here you're going to go which direction? Yeah, up 1, right 1. You got it. Or you go down 1, left 1 too. And then connect the dots. Okay, hopefully you got something that looks like this. Okay, something looks like that. Alrighty. The point of intersection is, again, -1, 2. It's the same system of equations that we talked about earlier. Okay? An ordered pair that makes a linear equation true is called a solution. Okay? The point that the two lines intersect is the solution to the system. And then finally, to solve a system of linear equations, the ordered pair must work for all equations. If you put both, that's okay too, but really it's for all. If you have 3 equations in your system, the answer must work in all 3. Okay? Most of the systems we're going to see, we're going to have 2 equations. Okay? All right, let's flip over to the back. We're going to fill in these blanks here, and I'm going to get you guys started on your assignment. Okay? So right here, okay, let's just look at these 3 different scenarios that we just talked about on the last paper too. Okay? Same kind of idea. So we have the different number of solutions for the systems of linear equations. All right, here you can see we have different slopes, right? Different slopes for these lines. This one's going up 1, right 1. This one's going like up 2, right 1, up 2, right 1 kind of thing. Okay. The lines blank. What do you think we should put there? Intersect. Very good. The lines intersect, so there is blank solution. 1. Okay, you can see it's right there. There's that 1 solution. The lines blank, yeah, are parallel or don't intersect. I'm gonna say are parallel probably. Okay, so there are blank solutions. No solutions, right? They never intersect. The lines are blank. Yeah, overlapping or the same, you could say that. I'm going to put the same. So there are how many solutions? Infinite or infinitely many solutions. Okay? Question?
Could you go back to the previous question, right? Previous problem question.
Yeah. Like on the other page?
Yeah.
On the above the side, right here?
How did you get -1 or what was the slope for both?
The slope for this equation was -2 over 1.
Right.
The slope for this one was 1 over 1. Okay? If there's not a number in front of the x, you can put a 1 there. And then make it a fraction 1 over 1. Yep, you're welcome. Okay, so what I've got for you guys for homework, all right, is you have some options. Yes, and you have some time to work on it in class. You're about 10 minutes, so I suggest you use that time. Okay, here's what you're going to be doing. Okay, number 1, option 1, you can choose to do this side of the paper, and you'll see here that you've got different systems of equations, okay, and you're going to graph them. When you graph them, okay, they're going to intersect at one of the UFOs. Okay, and so you're going to identify which UFO is hit by the 2 lines. Okay, when you graph it. Okay, remember it's got to be hit by both lines at the same time. Okay, so identify which UFOs are hit. Or if that's not what you're interested, if you're not interested in shooting down UFOs, you can just do these on the back. Okay, if you want to just try those, there's already some graph there, paper there for you. So your choice, front or back, but you got to do one. Okay, so your choice, you get to pick. Okay. All right, so let's see here. What's that? Absolutely, yeah. All right, so again, front or back. I'll get you one. Do you want one? You sure? I've got one over there. Okay. Oh yeah, and absolutely, Mr. Stever and I, Mr. Kurt here, we can all help you guys out. So if you're stuck on something, let us know. We'll be happy to come and help.
So just a
to graph this line, you're going to put your y-intercept there at -4, and then you're going to go down 1 to the, now right is this way. So yeah, like that. And there's the point. Okay? And just keep going. Down 1, right 1, down 1, right 1. Or up 1, left 1. Oh, you're going to go. Thanks. Yeah, no problem. And then grab the other line and see what UFO they hit. Okay? And you'll have to erase it then and fix, fit the other stuff on there too. Question? Yes, go ahead. Oh, I didn't get you one. I'm sorry. I think it's because you're in the back. I didn't count. Front or back, one or the other. You can just pick. It's your homework. One or the other, not both.
Okay, so one is
Front or the back, either one. That's your homework.
I'm sorry.
Yeah, that was great. Good job. So yeah, and so -4 is the y-intercept. So you actually don't want to sort of see that. There's a minus right there, so watch that. Okay. You good on that then? And then your slope is going to be -1 and positive. They should both intersect. Remember you in the first one? Be careful. That's a -1 over the slope. So you switch with the down one, right one. That's the y-intercept. Yep. Yes, that's correct. Now, do you have a pencil or anything? Because it's or that is I would suggest use a pencil because otherwise you're gonna have a ton of lines. It's gonna be hard to identify what's what. So, kind of see. Okay, this is the slope of -1. So down one, right one. Oh, this one's got a slope of +1. You went down one, right, which is not 1, right 1. So this slope should go this way. Like that. Feel okay on these things? Okay. Question? Start at the y-intercepts. Great question. So they're y-intercepts, right? One of those is the y-axis. That's it. Right, that's all there is to it. Well, you'll get quicker. Well, you'll get quicker at them if you just you might go just eyeball them. Like for example, for this guy, if you go to graph just this one, right? Here's 6, then you know the slope is 1. So up 1, right 1, well you're out of UFOs. Down 1, left 1, down 1, left 1. So you missed 5. The only way you're going to potentially hit 6, right? There's 1 or something on the line, so it's got to be 6. You see what I'm saying? So you don't necessarily have to do it, but you should. But you got to break it away. So for the first, second. Okay, so your slope is -1 over 1.
I'm still number 4.
So you get to choose. Either you can say it's -1 over +1, or you can say it's +1 over negative. So you can choose where you put the negative. Your choice. If you put the negative in the numerator, that means you're going to go down 1, and then right 1 because the positive on the denominator. Right? But alternatively, you can also go up 1 and then left 1. That's still the same answer, right?
I need help on number 4.
Okay. Let's try.
Okay. Start at -1, right? We'll go up 1 over. Put it before that?
slope-intercept form. Remember that, right? So we're looking to identify what's the y-intercept, and then also what's the m, the slope. Okay, so looking right here, what's the y-intercept of this line? What's the b in this line? 5. That's your y-intercept. So when you go to graph, you're going to count up 1, 2, 3, 4, 5. That's where you're going to put your first point for that line. Then what's the slope of this line? Good. Or as a fraction, negative 1 over 1. So then from this point you count down 1, right 1, and you put a point. And then you keep going and you'll build your line. And you just connect the dots. Okay? So far so good?
I'll see you Monday.
So you just keep going down 1, right 1, and just connect those dots like this. And then for this one, start at 1, go up 1, right 1, up 1, right 1. You can see your point intersect right there. Okay, just connect the dots to the 2 lines, and you should be okay when they intersect. Okay. Nope, you're welcome, Jeff, anytime. Are you coming after school today? Okay. Okay, I was gonna say I'll be there today.